In this video, we're going to cover off the what, the why, and the how. What it is, why you should consider doing it, and then how did you go about doing it. What is it? Okay. If you gain stage your DAW to external hardware, it'll allow you to directly translate your DAW signal levels through your DAW meters in DBFS to the analog levels required for your audio equipment. You can then set the gain levels within your DAW to be at the same level as external hardware line level, and making your external hardware compatible with your DAW. Why would you want to gain stage your DAW and the external hardware? Well, there's a couple of reasons for this. One is, if you operate at a consistent level within your DAW across your tracks and your buses, which is compatible with your audio equipment, you can then just patch in external audio equipment without worrying too much about whether the level you're hitting your equipment is correct. So you can then use external hardware inserts within your DAW into your external hardware and then come out, and it will make hybrid mixing a lot easier and smoother. It also reduces the risk of your master bus clipping the D to A converter at the end of it, because your individual tracks are too hot when they're combined. So one of the temptations in mixing in the box is that you end up with your tracks being quite hot, and then when you do your mix down, you find you're chasing your tail where your mix itself is clipping your D to A converter, and then you have to go back and rebalance. If you run at a level that's compatible with external hardware, what you'll find is the chances of that happening will be a lot less. If you want to establish this gain staging structure, you're going to need some things. You're going to need a digital multimeter, a DMM, so that you can enable and measure RMS voltage. You're going to need a signal generator plug-in in your DAW. Most DAWs have a signal generator plug-in provided free. And you're going to need a patch lead or a breakout lead, so you can actually plug that into your converter output that you're sending the signal generator to, and to be able to measure your output voltage. In your DAW, in the digital domain, 0 dBFS is the highest level that a signal can occur before clipping when you convert it back to analog by the D to A converter. Your DAW metering is calibrated to 0 dBFS. So if you look at your meters in your DAW, the top says 0 dBFS and everything else is negative below that. So that's the digital domain. In the analog domain, if you've got professional analog equipment, be it compressors, EQs, etc., they're designed to operate at a specific level, and that level is plus 4 dBu. Okay, so what does plus 4 dBu mean? Plus 4 dBu corresponds to 0 dBVU. 0 dBVU is if you have a VU meter on your external hardware, whether it's monitoring the input or the output, 0 dBVU corresponds to plus 4 dBu. Okay, so if you feed that bit of kit a plus 4 dBu level signal, the VU meter on your equipment will read 0 dBVU. That still doesn't tell you what that level is. So the definition of plus 4 dBu is if I feed a 1 kilohertz sine wave into the input and I measure the input voltage to be 1.228 volts RMS, that will correspond to 0 dBVU on the VU meter and a line level corresponding to plus 4 dBu. So, in summary, our problem here is in the DAW, we've got X dBFS, which is going to correspond to a +4 dBu level, which corresponds to 1.228 volts RMS, which then corresponds to 0 dB VU on the VU meter. And what we need to do is we need to establish that X. How many dBFSs correspond to 1.228 volts RMS when I measure it with my DMM. So how am I going to establish my gain staging? So first thing I'm going to do is I'm going to create a track with a signal generator with a sine wave at 0 dBFS output. So here's my signal generator. I've got that inserted on this track. I have it generating a sine wave at 150 Hertz and the level is 0 dB. So if I turn this on, before I do that, this tone generator, its output is routed to signal generator 2, which is routed to line out 3 on my interface. It's the line out 3 that we're going to monitor and measure the actual voltage coming out of it as I change this level on my tone generator. So we have to work out how many dBFSs correspond to an output of 1.228 volts, which is what we're going to do in a minute. I'm going to turn the tone generator on. And what you can see here is that this tone generator is generated a signal pretty much at 0 dBFS, which is going to output line out 3. Okay? So the next thing we're going to do is we're going to connect to line out 3 a patch cord, and we're going to measure the voltage. So I've got a patch cable here. I have a digital multimeter here. And what I'm going to do is I'm going to measure the voltage between the tip and the ring. I'm going to turn my voltmeter DMM on to AC volts. And at the moment, what I'm seeing is with the tone generator at 0 dB level, I'm seeing 6.13 volts. So what I'm going to do now is I'm going to turn down this level until I see the voltage that I want to see, which is 1.228 volts. Let's go back to the tone generator and slowly bring down the gain until I get 1.228 volts. And on my system, I can see now that if I put the gain of the signal generator to minus 14 dB, I'm getting 1.228 volts on my DDM. Minus 14 dBFS corresponds to 1.228 volts. Okay, cool. Now, just to check that, what we might do is we might turn the multimeter off. And what we're going to do is we're going to plug the output line out 3, which is what we've just measured. And we're going to plug that into the input of one of my hardware devices, which is a compressor. And what we'll do is we'll look at the VU meter. So now I've turned on the compressor. I've got the metering is set to input. And what I see on the VU meter is I see the VU meter at 0 dB VU. So now I've established my gain stage. For my converters, minus 14 dBFS corresponds to 0 dB VU, which is the standard line level for external hardware. Let's talk about the accuracy of your measurements. Your digital multimeter is an instrument, and as such, it only measures values to a certain accuracy. You need to look at the specifications of your actual device to determine the accuracy of the measurement that you're taking. In summary though, most cheap digital multimeters have poor accuracy for AC voltages at 1 kilohertz. This is why I've changed the signal generator to generate at 150 hertz, because you're going to get a more accurate reading on your multimeter. The actual RMS voltage generated isn't dependent on the frequency. So whether you generate the sine wave at 1K or at 150 hertz, the value will be correct in terms of the value won't change in terms of the RMS voltage, but what will change is that your digital multimeter will be able to read that more accurately at 150 hertz. So hopefully that's made sense. So what do I do with this information? So in my case, I know minus 14 dBFS equals 0 dBVU. Well, what I now know is that if I want to use external hardware, and I don't want to worry too much about the input levels that I'm feeding that external hardware, i.e. I want to make sure that the input levels are optimized for the hardware. If I run my tracks at around minus 14 dBFS from an average point of view, not a peak, that should be an appropriate level to drive that hardware. So if I gain stage my tracks within my DAW to approximately minus 14 dBFS, on average, everything should work nicely. If you've got any questions, leave some comments and I'll try and reply. Thank you.